atomic structure, some important point related electromagnetic wave. We discussed in previous lecture about frequency, wavelength, speed of light, time period, etc. Today we will discuss about amplitude, that is represented by a small a. Dear student, before the discussion amplitude, first you observe here a wave. This is the wave. Dear student, the maximum height of this here and maximum depth is here, maximum height is here. Dear student, the maximum height of the wave, or maximum height depth of the wave. Dear student, you know that the height of the wave is crest, whereas the depth of the wave is trough. So we say that the maximum height of the crest and maximum depth of the trough. Here maximum height of the crest, maximum height of the crest or maximum depth of the trough is known as amplitude. So we write here amplitude for A. The height of maximum height of crest represent amplitude and maximum depth of the trough is also represent the amplitude. So we say the amplitude of a wave is defined as the highest height of the crest and depth of trough. Yes, student, always remember the amplitude of a wave is defined as the height of the crest and depth of the trough. So here the maximum height of crest is amplitude and also maximum depth of the trough is also known as amplitude. Okay, I think you understand about what is the amplitude. Okay, dear student, now discuss important note. Dear student, you know that frequency is equal to c upon lambda. Frequency means nu is equal to c upon lambda. Okay, c is here velocity, nu is lambda frequency, and lambda is wavelength. And you also know that nu bar, this one nu bar means wave number is equal to 1 by lambda. If we put we need to put nu bar at the place of 1 by lambda, which is here 1 by lambda nu bar. So we obtained nu is equal to c into nu bar. Dear student, if in a questions number of wave numbers are given and asked about frequency, so you put here the constant 3 into 10 power 8 and into number of wave. Okay, student, and also if in a questions ask wave number and given frequency, then you put here frequency upon 3 into 10 power 8 equal to wave number. Okay, student. Dear student, now discuss electromagnetic spectrum. Dear student, electromagnetic spectrum in short written as EM spectrum. Okay. Dear student, the arrangement obtained by arranging various types of electromagnetic wave in order of their increasing frequency or decreasing wavelength is called as electromagnetic spectrum. Dear student, in electromagnetic spectrum, the arrangement of different frequencies wave. Electromagnetic wave. Electromagnetic spectrum is the arrangement of different frequencies wave in the order of increasing frequency or decreasing wavelength. Okay. Again, the arrangement obtained by the arranging various type of electromagnetic wave in the order of their increasing frequency or decreasing wavelength. So we say that electromagnetic spectrum or EM spectrum is the arrangement of various type of electromagnetic wave in which they arrange in their increasing frequency or decreasing wavelength. Here increasing frequency and decreasing wavelength. Why? Dear student, you know that wavelength is the inversely proportional to frequency. So we say that if we arrange the electromagnetic wave in the increasing frequency, it means it is the decreasing wavelength. As like here, the electromagnetic spectrums of the some radiations, some electromagnetic wave are given. For example, here student, the here the given wavelength of the some wave in angstrom. Dear student, observe here. You observe here the wavelength in of the electromagnetic spectrum is given. Basically, in this, you observe here as go to right in the spectrum. You observe here the wavelength of the wave decreases. Okay, so we say that when we going to right of this spectrum, we obtain shorter wavelength, shorter lambda. Lambda became shorter. Okay, but when you come right to left, then you observe here when you come right to left, the wavelength in angstrom increases. So we say that in the left, in this spectrum, wavelength in the left is longer, whereas the wavelength in right is shorter. It means this is the spectrum in which, in this spectrum, observe here the arrangement of electromagnetic wave, EM wave, in the decreasing order of wavelength. Okay, decreasing order of wavelength. Dear student, you know that frequency is inversely proportional to wavelength. Frequency is inversely proportional to wavelength. It means because here wavelength decreases, so we say that the frequency of the electromagnetic wave increases. It is because here the arrangement of electromagnetic wave in the decreasing order of wavelength. So we say that this order is the increasing frequency order. So we say that the wave which is present here is high frequency wave. Okay, look this. Dear student, this wave is gamma wave. Okay, dear student, it means gamma have the maximum frequency as compared to radio wave, infrared wave, visible wave. Okay, dear student, we say that here gamma have the maximum frequency as compared to radio, microwave, infrared, visible light, ultraviolet, etc. Okay, but gamma have the less wavelength as compared to this. Okay, so we say that in this spectrum, radio wave have the low frequency. and gamma wave have high frequency. Okay. Radio wave have longer wavelength, but gamma wave have shorter wavelength. Dear student, energy of a electromagnetic wave is directly proportional to their frequency. So we say that when frequency of the electromagnetic wave increases, then their energy also increases. Here we observe here high frequency of gamma, so we say that gamma have the high energy. Here radio wave have the low frequency, so we say that radio wave have the low energy as compared to gamma. Okay. Therefore, the important things is that here a resistance, that is a visible rays resistance. Student, visible rays, in visible rays you know that there are 7 colors of wave present, that is represented by Vibgyo. But dear student, the wavelength of the red light is maximum as compared to violet. So we say that the frequency of red is lower as compared to frequency of violet. So we say that violet light have in visible region, violet light have the maximum frequency as compared to indigo, blue, green, yellow, orange and red. But red have the highest wavelength as compared to orange, yellow, green, blue, indigo and violet. Dear student, please observe this spectrum and learn their order. Okay, and write down in your notebook. In next lecture, we will discuss Planck quantum theory. So, solve the questions related to this topic given in NCERT book. Thank you very much.